I've been working on a radio transmitter system using Wwise and Unreal Engine, and I thought it was time to show my work and talk through a bit of my process. I got started on this project after dipping my toes in single source ambiances in my current game project called GearGrit, demo out now. I was using the set multiple positions node in Unreal and a few different blueprints to emulate speaker systems with a single manager actor for each station, essentially trying to replicate real-life radio towers. But I wanted to combine the stations into a singular mega transmitter, working towards something more global and much more flexible. Doing some research into this, I found an Audiokinetic blog post from Brendon and Ellis. They're talking about their radio system in the 2022 reboot of Saints Row. It was quite cryptic overall, but Brendon mentions using a similar method that they used to achieve their implementation, so I knew I was on the right path. In my system, you have the main transmitter actor, which is more or less a manager class, and receiver scene components that can be attached to any actor. The transmitter lets the receivers know when it's initialized via an event dispatcher, and the receiver's feed updates to the transmitter via a radio helper interface. Individual stations are organized using a data asset class, which houses an AK event, radio station ID enum, and a transformer array. And then the stations are stored in a data asset array in the transmitter blueprint. New stations can be added to the system pretty easily. You just have to go into C++, make a new enum value in my enum script here, making a new data asset, and a play radio event in Wwise, assigning the values of the enum, and putting the asset into the data transmitter asset array. I was originally using a data table for this, and it looked nicer in theory, but it got to be pretty buggy when I was making and referencing instance structs to pass the transform data. The data asset approach just worked right out of the gate, so that's what I went with. So on begin play of the transmitter collates all these data assets. It creates an AK component for each. Then it adds that component to a map. Transmitter pops out an event dispatch saying that it's ready to go. The receivers then add themselves and their current station to another map. When all receivers in the level are found, the script continues and starts the play event on the appropriate transmitters. I originally had these events being auto-posted on the spawn at location node, but what would happen was if you're standing next to the transmitter, basically all the events would start at the same exact time right at the beginning, and based on the time I had set for the retriggerable delay, it would take a second to spit out the right transforms. So I got rid of that, and I opted for a sequence node and a gate for the post-associated event call here to avoid all that. As we move into one of the main functions, I loop through each of the stored data assets. I run some validation checks on the receivers to make sure they're not null, and if they are, I remove them from the map. If the receivers are tagged as having a movable transform, they get split out to a movable receiver array, which I'll handle later. If the remaining static receivers have an appropriate station ID value, they store their transform in this dummy array, and on completion of the loop, I store this new array in the data asset. I do a set multiple positions call on the mapped AK component value, then clear the dummy array to prepare for the next loop. If there are any movable receivers in the world, the script continues to another function where I append these transforms to the stored static ones. Over in Wwise here, the radio stations live in the interactive music hierarchy. You could put them anywhere, but for this demonstration, I thought it was more appropriate. Setting the voices to virtualize and play from elapsed time are very important because it guarantees all the radios stay in perfect sync with their host transmitter. There are only as many AK components and play events concurrently as entries in the data array asset, and you can see the voice counts remain low even though there may be tons of transmitters in the world. There's only ever going to be the amount of radio stations that you created, and set multiple positions node handles the rest. So that's basically the guts of it. Some functionality I added to the system. The ability to change stations with a little static interference event posting on the receiver's actors. I can spawn a new actor with the radio component at runtime, either static or movable. and I can destroy an existing one. And I can fire events for entering and exit a vehicle, or emulating that anyway, which do a few things. The enter event sets an RTPC, which removes any attenuation and any effects on that AK component, as well as 2D-ifying the source. It sets bus volumes for all the other stations to 0 as well. Exiting a vehicle resets all components back to their original values. Let's take a spin.
So you two dig up dinosaurs?
Towards the end of the project, I really wanted to start focusing on tick optimization. I realized I didn't need to check the transforms of movable and static receivers, every frame especially. What I needed to do was store any static transmitters when they're created, and then check the movable ones on a loop. In the current implementation, I check all the receivers in the world at begin play, separate out the movable ones, run the set multiple position nodes on the static receivers, and then start a loop on a timer that appends the transforms of the movable receivers to the static ones. If a new receiver is created, it runs the gauntlet again to place it in the correct bucket. I've learned a lot from Andy George's videos, Andy G. Bass on YouTube, and especially like his tick by distance function. And I'm using that concept in this project to further optimize these loops. In my system, I calculate the distance at the closest movable actor and set a tick value based on a clamped map range, maxing out at the attenuation range of the radio play events. This value then sets the time of the next loop. Only the actors in the attenuation range of the player are being sent to this function, keeping loop counts low to only audible actors. Any inactive receiver and/or any receiver outside that range is ignored until it comes back into range, as you can see here by the popping in and out of the debug strings. I'm also limiting the amount of movable receivers added to the array. This helps keep stress off the find nearest actor function, as things can get out of hand pretty quickly. As you can see in the Insights viewer here, the system runs pretty cheap actually, even with a lot of components. And it gets cheaper when you turn the debug off, obviously, because all of that's on tick. Well, that about wraps it up. Thanks for listening. Future goals for this project: I'd like to move everything to C++, make the transmitter actor into sort of a subsystem so it can be accessed globally. I'd like to add functionality for multiple transmitters and have a maximum effective range for each, sort of replicate reality in a way, with that RTPC breaking up the stations and adding in static white noise when you get too far away. And I kind of want to standardize the player inputs with bespoke events tied to either the interface or an actor component that handle communication with the interface and transmitter. Right now it's kind of a mess in the player controller. And that's it. Thanks for listening. If anybody wants to rip this system apart, I'd love to hear it. It's been a lot of fun working on it so far.